Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 12-3 Part 2 homework solutions on Cramer's rule. To solve this system using Cramer's rule, we're going to set up some matrices, and then I'll just find the determinants of them as I go. So our first one we'll set up is matrix A, the coefficient matrix. That has 4, 3, 3, and 2 in it. And the determinant of that, we're going to have 4 times 2, or 8, minus 3 times 3, or 9. So that'll be a -1 for that one. All right, we're going to set up another matrix B for the x values. So we're basically going to keep all the coefficient matrix stuff, but we're going to replace the x column here with the constants, 5 and 4. So there's matrix B. And the determinant of that, we're going to have 10 minus 12, giving us -2. And then finally, we'll set up matrix C, where we're just going to replace the y column here with 5 and 4. So the determinant of that, we're going to have 16, that's 4 times 4, minus 3 times 5, 15, which all comes out to +1. Now to find the x value, that's going to be the determinant of B over determinant of A. So that's -2 over -1, which we can reduce to 2. For the y value, we've got determinant of C over determinant of A. So that's going to be 1 over -1, which reduces to -1. So then we can write the point 2 comma -1 for our final answer. To solve this system using Cramer's rule, we're going to set up and find determinants for 3 different matrices. One is going to have the coefficients. One is going to have the coefficients minus the x column. We're going to put the constants in there instead. And we'll do one that has the constants substituted for the y coefficients. So let's do them one at a time. For A, that's the coefficient matrix. We've got 5, -1, -1, and 6. And then the determinant of that, we're going to have 5 times 6, or 30, minus -1 times -1, so that's going to be minus +1, and that comes out to 29. Next up, for B, we're going to keep the coefficient matrix, except we're going to replace the x column here with 12 and -14 from the constants. And then finding the determinant of this one, we have 12 times 6, or 72, and then we're subtracting -14 times -1, so subtracting +14, giving us 58. For my C matrix, I'm going to just replace the -1 and the 6 from the coefficient matrix with the 12 and the -14. So the 5 and the -1 stick around, 12 and -14 are now taking the place of the y coefficients. And then if I find the determinant of this one, we've got 5 times -14, which is -70, minus -1 times 12, so that's +12, and that comes out to -58. So to find the x value, I need the determinant of B over the determinant of A. That's going to be 58 over 29, which gives us 2. And then for the y value, I have determinant of C over determinant of A. So -58 over 29, which comes out to -2. So then our solution for this one is going to be 2 comma -2. To solve this 3x3 system with Cramer's rule, I'm going to first set up 4 matrices. One of them will be my coefficient matrix. It'll be a 3x3. And the other 3 will be the coefficient matrix, but I'm going to swap out one column for x, y, and z each, and then I'll put these constants in there instead. So let's start with our coefficient matrix. We've got -1, 1, -4, 3, 5, -6, 2, -3, and 5. So just all the coefficients from the variable part of my system of equations. And now let me do a B matrix where I keep basically all this stuff, except I'm going to replace this x column with my constants, -7, -5, and 12. Next up, I'll do a C matrix where I keep all this stuff, but I swap out the middle column, and I'll put the constants in there now. And then a D matrix where I'm going to swap out this Z column for, you guessed it, -7, -5, and 12. Everything else from the coefficients matrix staying the same there. So now, in order to figure out my various x, y's, and z's, I'm going to have to enter all these in my matrix, in my Desmos matrix calculator. So let me go ahead and do that now. I'm in the matrix calculator. I'm going to do new matrix, and this will be my A, which I'm going to make a 3 by 3. So we've got -1, 1, -4, 3, 5, -6, 2, -3, and 5. And now let me make another matrix for B, also a 3 by 3. So that's -7, 1, -4, -5, 5, -6, and then 12, -3, and 5. New matrix. We'll make a C matrix now. And that's going to have everything down here. So -1, -7, -4, 3, -5, -6, 2, 12, and 5. And then finally a D matrix, also 3 by 3, which will have -1, 1, -7, 3, 5, -5, and 2, -3, 12. So now that I've got all of those, to find the x value, I need to do the determinant of b divided by the determinant of a, and I'll do that completely on the calculator. So let me just enter down to another entry, and then we'll do det of b with a parentheses divided by determinant of a, and that comes out to 2. Next up, for the y, I'm going to do determinant of c over a. So I'll just go back here in Desmos and replace the b with a c, and that's going to be -1. And finally, for z, I need determinant of the D matrix divided by determinant of a. So back in Desmos, change out the c for a d, and that's going to be +1. So then my final point for an answer, we've got 2, -1, comma +1. To solve this 3 by 3 system, I'm going to set up 4 matrices and then use the Desmos matrix calculator with Cramer's rule to finish the job. So my first matrix, matrix A, that'll just be the coefficient matrix. So just all the coefficients for the left part of the equations. We'll have a 2, -4, a 7, -3, 5, -1, and then finally we'll have a 1, -6, and a 1. For my B matrix, I'm going to keep all the stuff in the A matrix, but I'm going to swap out this x coefficient column with the constants. So instead of writing 2, -3, and 1, I'm going to have -1, 26, and 24 in there. And then for matrix C, I'm going to just replace the middle column, the y column in matrix A, with the constants here. So basically what I did for the B matrix, only middle column instead of left column. And then for the D matrix, I'm going to swap out the Z column here that's in the A matrix with these constants. So I still have the 2, -4, -3, 5, 1, and -6, but I'm now going to put in the -1, 26, and -24 over here. So let me put all these in my Desmos matrix calculator. So in the matrix calculator, I'm going to do a new matrix for A, and I'm going to make that a 3 by 3, and I'm actually going to do that for all of these I put in. Defaults to 2 by 2. So here's my A matrix. Let's see what else. We got -3, 5, -1, 1, -6, and 1. New matrix. Here's my B matrix, and that's going to be -1, -4, 7, 26, 5, -1, -24, -6, 1. Now on to the C matrix, which has 2, -1, 7, -3, 26, -1, and 1, -24, and 1. And finally, the D matrix, also a 3 by 3. That's got 2, -4, -1, -3, 5, 26, 1, -6, and finally -24. To get the x value, I need to do the determinant of b divided by the determinant of a. Let me do that on my calculator. So determinant b with parentheses divided by determinant a comes out to -3. Seems likely. And now for the y value, I'll do determinant of c divided by determinant of a. So back on the calculator, just replace the b with a c, and we've got positive 4 for the y value. For the z, I need to do determinant of d divided by determinant of a. Too many d's going on there. Let me just replace c with d, and that becomes 3 for the z value. So then, final answer, we've got negative 3, comma 4, comma 3. For this problem, we've got a word problem going on. There are X occupied floor seats and Y occupied balcony seats at a concert with 6,700 total attendees. The tickets cost $40 per floor seat and $25 per balcony seat. Total revenue is $185,500. Write and solve a system to determine the number of occupied seats of each type of the concert. So this is a pretty standard systems of equations problem. We have one equation talking about just the number of seats and what it adds up to. We have another equation talking about the money generated from all the seats and what all of that adds up to. So with these two equations, we'll be able to figure out how many floor seats and balcony seats there were at the start of all this. So let's start by writing a system. So let's do an equation now for just the number of seats. We've got the number of floor seats, X, plus the number of balcony seats, Y, and that's all the seats, so that should add up to the 6,700 total attendees. And then, by the way, we're talking about occupied seats, not total seats. So just to be specific, these are only seats with people in them. All right, so let's also move on to the next equation. We have $40 per floor seat, so that's going to be 40x plus $25 per balcony seat, so 25y. And if we add up the money from the floor seats and the balcony seats, that all adds up to $185,500. Cool. So now we're going to solve this using a system of equations. Now we could do this with just good old elimination method and it would be fine, but I want to show off the Cramer's rule in this homework, so we're going to use Cramer's rule for this. To do that, we will set up three matrices. My first matrix, A, is going to be my coefficient matrix. That's going to have 1, 1, 40, and 25 in it. Matrix B will be this A matrix, but I'll swap out the X column for the constants here. So I'll still have the 1 and the 25, but now I'm going to replace the 1 and the 40 with 6,700 and 185,500. And for my C matrix, I'll do pretty much the same process, but this time for my A matrix, I'm going to replace the 1 and 25 in that second column, the Y column, with these two constants. And I'm going to do all of this with the matrix calculator, so let's go ahead and enter these in that calculator. So here I am in the calculator. Let me do new matrix, and it calls it A for us. We've got 1, 1, 40, and 25. Let's do another new matrix, B. That's 6,700, 1, 185, 500, and 25. And our last matrix, C, has 1, 6,700, 40, and again 185, 500 with no comma in there. So to get the X value, I need to do determinant of B over determinant of A. Going back to Desmos and doing that, determinant of B divided by determinant A comes out to 1,200. So we got 1,200 floor seats. Next, for the Y's, I need determinant of C over A. Going to Desmos, I'm just going to replace the B with a C. That's 5,500, so that's the number of balcony seats. For this problem, we have a table showing molecular masses in AMUs of 3 different compounds. They want us to use a linear system and Cramer's rule to figure out the atomic masses of the elements sulfur, chlorine, and calcium. So the basic idea here is if you add up the masses of the individual atoms in each of these formulas, it adds up to this molecular mass over here. So each of these 3 compounds actually gives us enough information for a separate equation. All 3 of these together form a system of equations that we can solve for the individual elements' masses. So just to make my life a little bit easier, I'm going to rename these with different variables. I'm just going to use X, Y, and Z, and I'm going to write these in alphabetical order as well. So I'm going to let X represent the mass of calcium, Y is going to be the mass of chlorine, and S, or Z rather, will be the mass of sulfur. And really, my biggest reason for doing this is that we've got two different elements that have a C to begin with, so that's going to be kind of confusing if I try to sort those out a different way. So let me write out our equations here. So our first compound has no calcium in it, so that's going to be 0 for the calcium, so 0x. We do have two of these chlorines, so plus 2y, and we have a sulfur, so plus 1z, and that all adds up to 103 AMUs. Next up, we have one calcium, so 1x for that next one. We have two chlorines, so 2y's, and 0 sulfur, so 0z, adding up to 111. And then for our last equation, we've got one calcium, 1x, no chlorine, so 0y, and one sulfur, so 1z, adding up to 72. And even though I don't have any of these elements with zeros, I do want to put placeholder zeros in there because I'm going to be converting this into a matrix, and it's helpful to know that there is a numerical value there, even if that value is nothing. So I'm going to write four matrices now. One of them is going to have all the coefficients in it. That'll be my A matrix. And then for my B, C, and D matrices, each of those is going to replace a separate column from this original coefficient matrix with these atomic masses, 103, 111, and 72. So let's implement this, and then we can use our calculator. So for my A matrix, I've got 0, 2, 1, 1, 2, 0, and 1, 0, 1. For my B matrix, I've got everything in the A matrix except I'm going to replace the first column, the X column, with 103, 111, and 72, my constants here. For the C matrix, I'm going to keep my A matrix, except I'm going to replace the middle column with my red constants here. And then for my D matrix, again, I'll start with the A matrix, but I'm going to swap out the Z column now for 103, 111, and 72. At this point, I need to enter these matrices in my Desmos matrix calculator. So I'm going to start by making a new matrix, and it'll automatically call it A. Let me make that 3 rows and 3 columns, and I'll do that for all of these here. So that's going to be 0, 2, 1, 1, 2, 0, and 1, 0, 1. Next, let's make a B matrix, 3 rows, 3 columns. We've got 103, 2, 1, 111, 2, 0, and 72, 0, 1. Next up, C matrix, 3 columns, 3 rows. We've got 0, 103, 1, 1, 111, 0, and I need to go back to my screen to see what's down here, 1, 72, and 1, so let me put that in. And then finally my D matrix, 3 and 3. Let's do 0, 2, 103, 1, 2, 111, and 1, 0, 72. 1, 0, 72. There we go. All right, so now that I've got all of these, to find the X value, that's the mass of calcium, I need to do the determinant of B over the determinant of A. Let me do that on Desmos. So determinant B divided by determinant A comes out to 40, so that's 40 AMUs. And then for the Y, I need to do determinant of C over determinant of A. Back on Desmos, swapping out B for C gives us 35.5 AMUs. And finally, for the Z value, that's determinant of D over A. So back on Desmos, changing out the C for a D, we end up with 32 AMUs.